For this video, I will be proving the De Morgan's laws for logic. And we have number 1 here, the negation of P and Q, double implication, not P or not Q. Basically what we're saying is that this is equivalent to this. So we're going to go ahead and write out our terms in what we want to prove. And we have P, Q. We have not P, not Q. We have P and Q. We have the negation of P and Q. And we have not P or not Q. So P and Q can only take on two values. It is true or it is false. So we are going to go ahead and write different combinations. So P can be true while Q is true. P can be true while Q is false. P can be false while Q is true. P can be false while Q is false. So our negation of P, we have T, which is true. So negation becomes false. Negation becomes false. Negation becomes true. The negation becomes true. And now for Q, we have the negation of T is just F. The negation of F is just T. The negation of T is just F. The negation of F is just T. And here we have P intersect Q. And P intersect Q, which is P and Q, is true only when P and Q is true. So P and Q right here is true. So P and Q becomes T. We have a false here, so that P and Q is false. We have another false here, so that means P and Q is false also. And we have two false here, so that means P and Q is false. So for the negation of P and Q, we have T. This becomes F. Negation of F, that becomes T. The negation of F, that becomes T. The negation of F, that becomes T. And what we want is now is the negation of P or not Q. And if either P or Q is true, then P or Q is true. So here we have P and Q, not P and not Q being F. So that here we have not P and not Q, F, T. So this becomes true. Here we have T and F. This becomes true. And here we have not P or not Q is true. And if we look at these two columns, not P and not Q, the negation of P and Q and not P or not Q, then we notice that our truth values outcome is the same, and therefore it is proven that